Hey everyone, welcome to the channel, and in this video I am going to talk about problem number 98 of lead code. And the problem is like validate binary search tree. So in this video I'm going to talk about this. Given the root, you have given a root of binary tree, and you have to determine if it is a valid binary search tree or not. So how we can perform this and make this code possible for this. So if you don't know what is a valid VST, so in the VST, the left subtree of the node contains only nodes with key less than the nodes key, and the right subtree of a node contains only nodes with keys greater than. So if you have a node, and if you have here 2 and here 1, and this in the right, it is it. So this is a valid VST because the root is greater than left. Okay, so this is greater, root is greater than left and less than 3. So this is valid. But if we have a tree like this fails because in the by st you have you have to be a greater root value than left value. So this is false. So now in this question our task is to make our code possible. So how we make? So in the question, if you see the question, we have to return the boolean values. Okay, and in the function they pass root of the tree. So what we do, we make another function which is also a boolean. So we make a function like the name of the function is valid bst, and we pass root of the tree, and then we pass null values, two null values. And what is these two null values? These are minimum and maximum integers. Okay, these are minimum because if what we have to compare, we have to compare the current node. This is, if this is current node, we have to compare with the minimum. And what is maximum here? Maximum in this case is 3, and what is minimum in here? The minimum is 1. So we have to compare 2 with minimum and maximum. If this is okay, then okay, we have binary BST, a valid BST. And if you're not, this is not. So in this case, just check with 1. If 1 is greater, yes. See here, there are 3 for 3, 4 is greater and less. So what is maximum here? So in this case the maximum is 6 and minimum is 1. Okay, so now let's start what is the code. So the code is in the function, the function which I made, which is valid bst. Okay, and in this I pass the root which I named as node. In the above function it is root, but now in this function I am naming different than the root. So in this function I am saying root as node, and we have two functions, we have two parameters, integer min and integer max. Okay, so in this one, the first of all we check the condition if node is equal to null. So what we get? If we get node is equal to null, so we have to return true. And if, and now this is the most important statement, which is I am checking whether it is a valid BST or not. So how we check? So let's say if you have the a node, and here you have here 2, and then here 3, and there 1. So you have a node 2, 1, 3. So just check if this element, is greater than min. If if this element is less than min. Okay, so what this means? This means this is not valid. Okay, and if this element is greater than min, then max, so in that case also this is not valid. Okay, so here we have two cases. If our element, root element, is less than root dot value, then also it fails. And if we have max the root dot value, then also we get failed. Okay, and in this case minimum, our root dot value is minimum than min, and in the another case max root dot value is greater than max. Okay, so in both the cases we get false value. So first of all check if root dot value, if what here we named it as node, so node dot value is greater than max. If we have greater than or equal to max and node not equal to null. If node is not null, then this is the condition. But okay, what is the condition? If min is not null. If min is null, then it's okay. But if min is not null, and then we are getting just node dot value is max is not null, node dot value greater than max, then this is not okay. And then or if node dot value less than or equal to min and min not equal to null, then this is a condition of false. So in this case we false return. Okay, and if this is not the condition, then our function return false. So first so for that we checked it like is valid bst, and then pass node dot left. So this is the condition for checking node dot root, and the same function you can call in other also. And your minimum is node dot value and is valid bst node dot right min node dot value. This is node dot right. Okay, so in this we are comparing with max, and if node dot left we are comparing with minimum. And here we used and why we used and? This means if these conditions fails, this also fails. Okay, so that's why we are using and. Like if you have a 2 and 1 and 3, if this condition fail, if here you have 4, so if this condition fail, this is obviously not a valid bst. That's why we are using and here. Okay, so this is our answer. First of all we checked if node is equal to null, then return true. If node dot value, if node's value greater than max or node's value less than min, then return false. And if it is not the case, then in that case you have to return is valued bst, which is node dot left min and node dot value. Okay, and take and. So this is my answer. And for making such videos, please subscribe my channel. Please subscribe and share with your friends. Thank you.